Look at the next question. Find two positive numbers x and y such that their sum is 35 and the product x square into y raised to 5 is a maximum. So here also we have to find two numbers whose sum is 35 and the maximum product when the product of x square and y raised to 5 is maximum. So what are the two numbers? So here it is given x and y are two numbers. So x plus y is equal to 35. Their sum is 35. That implies y is equal to 35 minus x. Right? So what is our function? X square into y raised to 5. So here we have to make that y terms to x terms. Okay. So x raised to x square y raised to 5 is equal to x square into what is y? 35 minus x whole raised to 5. Okay. So what is our function? F of x is equal to x square into 35 minus x whole raised to 5. Now let's find f dash of x. F dash of x is equal to, that is derivative of x square into 35 minus x whole raised to 5. It is the product of two functions. So here we will apply product rule. X square into derivative of 35 minus x whole raised to 5 is 5 into 35 minus x whole raised to 4 into derivative of 35 minus x is nothing but minus 1 plus second function, that is 35 minus x whole raised to 5 into derivative of x square is 2x. That is equal to, here 35 minus x whole raised to 4 is common in both terms. So let's take it out. X into 35 minus x is also common, right? So we will take x into 35 minus x whole raised to 4 into, here remaining minus 1, 5x. So minus 5x plus here we have taken 35 minus x whole raised to 4, right? So remaining and x into x, okay? So remaining 2 into 35 minus x. That is equal to x into 35 minus x whole raised to 4. Here minus 5x plus minus 2x, that is minus 7x. 2 into 35, 70. So 70 minus 7x. Okay. Now for critical points, f dash of x is equal to 0 implies x into 35 minus x whole raised to 4 into 70 minus 7x, that is equal to 0. This implies x is equal to 0 and 35 minus x whole raised to 4 is equal to 0 implies x is equal to 35, right? X is equal to 35 and 70 minus 7x is equal to 0 implies x is equal to 10, right? 70 minus 7x is equal to 0 implies 7x is equal to 70, x is equal to 70 by 7, so x is equal to 10. Then these are 3 points. Okay, next we will find f double dash of x. F double dash of x, that is differentiate these functions, these terms with respect to x. So here 3 functions, product of 3 functions. So here let's consider this as first function and this as second function, then apply product rule. So x into 35 minus x whole raised to 4 into derivative of 70 minus 7x is nothing but minus 7 plus second function into 70 minus 7x into derivative of this one. That is, here again we have to apply product rule. X into 35 minus x whole raised to 4 is 4 into 35 minus x whole cube into minus 1, okay, plus 35 minus x whole raised to 4 into derivative of x 1. That is equal to minus 7x 35 minus x whole raised to 4 plus 70 minus 7x into, here see 35 minus x whole cube is common, right? So let's take it out. 35 minus x whole cube into, here remaining minus 4x, here minus 35, no minus, right, plus 35 minus x, 35 minus x. So this can be written as 35 minus 5x, right? That is minus 4x minus x minus 5x. Okay. So here what are our points? X is equal to 0, x is equal to 35, x is equal to 10. Okay, see first of all let's substitute x is equal to 0. See, if substitute x is equal to 0, this first term will be 0 and the second term here we will get, see, substitute x is equal to 0, this will be 70, then here 35 cube and here 35. See, here we will get f double, when we substitute x is equal to 0, f double dash of 0 will be greater than 0, right? See, you can check it. See, when here first term will be 0, put x is equal to 0 here, we will get 70 and here this term 35 whole cube and into 35, that will be greater than 0. That means the function is minimum at x is equal to 0. Okay, so it's x is equal to 0 is not possible. So next, when x is equal to 35, here substitute x is equal to 35, the first term will be 0 and here also second term, see, here also if we substitute x is equal to 35, this will be 0, means totally it will be 0. So here in this case also x is equal to 35 is also not possible. So here what about x is equal to 10? So at x is equal to 10, here you can write x is equal to 0 and x is equal to 35 are not possible. Okay, so next at x is equal to 10. At x is equal to 10, see here at x is equal to 10, here 35 minus 10, that is 25 whole raised to 4 and minus is here, plus here it will be 0, right? It will be 0 when substitute x is equal to 10, this second terms completely will be 0 and first term will be minus 7 into 10, then 35 minus 10, that is 25. So here this first term will be minus. Okay, so here at x is equal to 10, f double dash of 10 is less than 0. Okay, just substitute x is equal to 10. So here minus 7 into 10 minus 70 into 35 minus 10 is 25, 25 raised to 4, that is positive, so into minus, so that will be less than, minus, so less than 0. So at x is equal to 10, f double dash of x is less than 0. Therefore, this function, that is this function has maximum at x is equal to 10. Okay, so f of x has maximum at x is equal to 10 or when x is equal to 10. That means the product, what is our function? F of x is nothing but product of x square and y raised to 5. The product x square into y raised to 5 is maximum when x is equal to 10. So what is y? When x is equal to 10, y is equal to 35 minus 10, that is equal to 25. So what are the two numbers? 10 and 25. X is equal to 10, y is equal to 25. Okay. So what is the maximum product? So just to substitute x. So here it is not asked, only the numbers, right? X and y. Finding two numbers, x and y. So x is equal to 10 and y is equal to 25. Find two positive numbers whose sum is 16 and sum of whose cubes is minimum. So here we have to find two numbers whose sum is 16 and the cube of their sum of their cubes is minimum. So when it is minimum, what are the two numbers? So let's take, let x and y be two numbers. Okay. And it is given their sum is 16. So x plus y is equal to 16. That implies y is equal to 16 minus x. So what is our function? Here function is nothing but f of x is sum of their cubes. That is x cube plus y cube, right? So x cube plus y cube. Here we have to change y terms to x terms. So x cube plus y is 16 minus x. 16 minus x whole cube. So what is our function? F of x is equal to x cube plus 16 minus x whole cube. Then find f dash of x, 3x square plus 3 into 16 minus x whole square into minus 1. So here 3 is common. Let's take it out. 3 into x square minus 16 minus x whole square, right? That is equal to 3 into x square, here minus of 16 minus x whole square is x square minus 32x plus 16 square, right? That is equal to 3 into x square minus x square cancelled. So 32x minus 16 square. So here 16 is common. Let's take it out. 16 into 3. Here 2x minus 16, right? Minus 16. Again we can take 2 outside. So it will be 16 into 3 into 2, 6, x minus 8. Okay. So f dash of x is equal to 0 implies 16 into 6, that is 36, 96, right? Okay. So 96 into x minus 8 is equal to 0. That implies x minus 8 is equal to 0 implies x is equal to 8. Okay. Next we will find f double dash of x. F double dash of x is equal to, what is our f dash of x? 96 into x minus 8. So 96 into derivative of x minus 8 is 1, right? So it's greater than 0. So f double dash of x is greater than 0. Therefore f double dash of 8 is also greater than 0. Okay. So here this function is minimum at x is equal to 8. Okay. So here we can write f of x is minimum at x is equal to 8. What is our function? What is our f of x? That is sum of their cubes, right? X cube plus y cube is minimum when x is equal to 8. And what is y? Y is also 8, right? Y is equal to 16 minus 8, that is 8. So when x is equal to 8 and y is equal to 8, the sum of their cubes is minimum. Okay. A square piece of tin of side 18 cm is to be made into a box without a top by cutting a square from each corner and folding up the flaps to form the box. What should be the side of the square to be cut off so that the volume of the box is the maximum possible? Okay. So here, first of all, a square piece of tin of side 18 cm. Okay. See here, suppose it's a square piece of tin. Okay, side 18 cm. Okay, all sides are equal because it is a square. Okay, and here we have to make it a box. Okay, we have to make a box from this. How? By cutting off a square from each corner. Okay, we have to cut off squares from each corner and folding up. Okay, that is, see, after cutting off squares from each corner and by folding up these sides to form a box. Okay, to form a box. Here what we have to find is, see, when the volume of this box, okay, when the see, after folding we will get a box, right? So after, see, when this volume of the box is maximum, so what is the side of these squares to be cut off? Okay, what is the side of these squares to be cut off? That we have to find. Okay, so here let's take, let x be the side of square to be cut off. Okay, here we have taken x is the side, x is centimeter, x be the side of the square to be cut off. Okay, so here then what is the function? What is our function? Here volume of the box is minimum, right? So our function is nothing but volume of the box. So first of all, let's write dimension of the box. Okay, so that means length, breadth, height, right? So to find the volume, here we know that, see, initially it was 18 centimeter each side, right? Initially it was 18 centimeter. But after cutting off squares from each corner, so what is the length? See here, we cut off See, we cut off squares from each side, right? So here its length is, what is the side is x, right? So x plus x. Initially it was 18 centimeter. Now it is 18 minus 2x because x plus x. Okay. So its length is, the dimension of the box is 18 minus x. Another side is also 18 minus x because since it was square. Okay, 18 minus x, 18 minus x. And what is the height? See, we have to make a box by folding up this one, right? So here the height is nothing but x. So x. So what is the volume of this box? That is their product, right? So volume is equal to 18 minus, not x, okay, 2x. Sorry, not x, 2x. Because we cutting off the squares from each side, right? So x plus x, 2x. So 18 minus 2x. So 18 minus 2x into 18 minus 2x into x. So it is the volume. Okay. So here we have to find, okay, let's find the first derivative. Okay, it's our function v, then dv by dx. Don't be confused finding the derivative. If it is f of x, then f dash of x. Okay, same dv by dx. That is equal to, here 18 minus 2x whole square, right? So here 2 is common. Let's take outside. So first of all, 2 into 9 minus x whole square into x. Okay, it's our f of x. Okay, volume. Then let's find dv by dx. dv by dx is 2x into derivative of 9 minus x whole square is 2 into 9 minus x into minus 1 plus here 2x to 9 minus x whole square into derivative of x is 1. Okay, that is equal to applied product rule. Okay, we have taken 2x as first function, then after that 2 into 9 minus x whole square second function. So here 2x into, or you can take 2 outside. Okay, 2 into, that is, then after that you can differentiate, otherwise it will be, the calculation will be wrong. Okay, so here 2x into 2 into x 9 minus x into derivative of 9 minus x minus 1 plus next 2 into 9 minus x whole square into 1. Okay, that is equal to minus 4x into 9 minus x plus 2 into 9 minus x whole square. Here 9 minus x is common. Let's take it out. 2 is also common. So 2 into 9 minus x into here minus 2x plus 9 minus x. That is 2 into 9 minus x into here minus 2x minus 3x. So 9 minus 3x. Okay. Then here dv by dx is equal to 0 implies 2 into 9 minus x into 9 minus 3x is equal to 0. That implies 9 minus x is equal to 0 implies x is equal to 9, and 9 minus 3x is equal to 0 implies 3x is equal to 9, x is equal to 3. Okay, x is equal to 3. Then here see x is equal to 9. See, when x is equal to 9, see what is our side will be? It will be 0, right? So it's not possible. X is equal to 9 is not possible. So let's take x is equal to 3. Because see, just to substitute, if x is equal to 9, so 18 minus 18, then side will be 0, right? So here it is not possible, right? So x is equal to 9 is not possible. Okay, next we will find d square v by dx square, second derivative. Okay, because here we should get volume of the box is maximum. Okay, so when it is maximum, what is the side x? Okay, so here d square v by dx square is 2 into 9 minus x into derivative of 9 minus 3x is minus 3 plus 2 into 9 minus 3x into derivative of 9 minus x is minus 1. Okay, that is, here see in both terms minus is there. So and 2 minus 2 take outside. So 9 minus x, 3 into 9 minus x here plus 9 minus 3x. Okay, minus taken outside. So minus 2 into here 27 minus 3x that is minus 6x. So 27 plus 9 that is 36. 36 minus 6x. Okay, 36 minus 6x. See, if we substitute any values of x, this will be less than 0, right? Okay, let's substitute x is equal to 3. If we substitute x is equal to 9, it will be 0. Okay, that is not possible. Okay, so at x is equal to 3, what is d square v by dx square? See, substitute x is equal to 3. So minus 2 into 36 minus 18, right? 36 minus 18, that is 18. So it is less than 0. Okay, we have got it is maximum, right? So that is f double dash of c less than 0 means that function is maximum at that point. Okay, so here we have got d square v by dx square at x is equal to 3 is less than 0. That means this function, that is v is volume is maximum when x is equal to 3. Okay, so we can write v, that is volume of the box. So volume is maximum. Volume is maximum when x is equal to 3 centimeter. Okay, x is equal to 9 is not possible because when we substitute x is equal to 9, this will be 0. Okay, so here x is equal to 3. When x is equal to 3, d square v by dx square, we have got it is maximum. So therefore this volume is maximum when x is equal to 3 centimeter. A rectangular sheet of tin 45 cm by 24 cm is to be made into a box without top by cutting off square from each corner and folding up the flaps. What should be the side of the squares to be cut off so that the volume of the box is maximum? So similar question, see in last question it was a square piece of tin, right? But it is a rectangular piece of tin, and same thing, the process is same, and we have to make a box by cutting off squares from each corner. So here is the question is when the volume of the box is maximum, so what is the side of the squares to be cut off? Okay, so here also let's take, let x be the side of the squares, to be cut off. Okay, then what is our function? Volume of the box. So first of all, let's write dimension of the box. See here, it is a rectangular sheet. Initially, this side is 45 cm, two sides are 45 cm and two sides are 24 cm. Length is 45 and breadth 24. So after cutting off squares of side x, then what is the dimension? That is, we cutting the squares from each side, right? So here 45 minus 2x, x plus x, right? So here the dimension of box is 45 minus 2x, then breadth 24 minus 2x, then what is the height of the box? X itself, right? X. Okay. So here, what is the volume? Volume is nothing but their product. So volume is equal to 45 minus 2x into 24 minus 2x into x. It is our function, right? So let's multiply this one. 45 into 24, 1080. Here minus 48x minus 90x into plus 4x square into x, right? That is equal to 1080 minus 138x plus 4x square into x. That is 1080x minus multiplied 138x square plus 4x cube. Okay, now let's find dv by dx. dv by dx, okay, differentiating with respect to x, same as f dash of x. Okay, so here 1080 minus 2 into 138, that is 276x, right, plus 4 into 3, 12x square. Okay, then dv by dx is equal to 0 implies here, okay, here 12 is common, right? Let's take 12 outside. That is 12 into 12 9s are 108. So 90 minus 12 2s, that is 23x plus x square. Okay. So dv by dx is equal to 0 implies 12 into 90 minus 23x plus x square, that is equal to 0. See, how can we factorize this one? See, multiplication is 90 and the sum is minus 23. That is 12 into x minus 18. Minus 18 minus 5. Okay, minus 18 minus 5. X minus 18 into x minus 5, that is equal to 0. This implies x is equal to 18. X minus 18 is equal to 0 implies x is equal to 18. X minus 5 is equal to 0 implies x is equal to 5. So we have got x is equal to 18 and x is equal to 5. Okay, now let's find d square v by dx square. See, it is our dv by dx, that is minus 276 plus 24x. Okay, see here, when x is equal to 18, see, we have to find the maximum, right? So when the function is maximum, right, so we should get less than 0. Okay, so when x is equal to 18, see, 24 into 18, that should be greater than 276. So it will be greater than 0. Okay, when, see, d square v by dx square greater than 0 when x is equal to 18. Okay, but we should get less than 0. Okay, when it is greater than or equal to greater than 0 means this function is minimum at x is equal to 18. Okay, but here we should get the function is maximum at which point? Okay, at what is the value of x? Okay, so here d square v by dx square. See, if you substitute x is equal to 18, this 24 into 8 is always greater than 276, right? So here you will get a positive number that is greater than 0. So here x is equal to 18 is not possible. See, not only that, here when you substitute x is equal to 18, 24 minus 2 into 18, that is 36, you will get a minus. So that is the length of a side is minus is not possible, right? So here we can say x is equal to 18 is not possible. X is equal to 18 is not possible. Okay, and x is equal to 5. So when x is equal to 5, see, 24 into 5, that is 12, right? Okay, 120. So minus, it will be minus. So at x is equal to 5, d square v by dx square less than 0. That is minus 276 plus 120. That is will be minus. Okay. So d square v by dx square less than 0 when x is equal to 5. So here we can say volume is maximum when x is equal to 5. That is side of the squares to be cut off is equal to how much? 5 centimeter. Okay. So volume is maximum. I will write here. Volume is maximum when x is equal to 5 centimeter, or therefore the side of the squares, see here we have to write the side of the square, right? Okay, side of the squares to be cut off is equal to 5 centimeter. Okay, that of all the rectangles inscribed in a given fixed circle, the square has the maximum area. Okay. See here, first of all, let's take a rectangle inscribed in the circle. Then here we have to show when it is the maximum area, it will be a square, not a rectangle. Okay, that we have to prove. Okay, so first of all, here let's take x and y be the length and breadth of the rectangle respectively. So x and y be the length and width of the rectangle, and r be the radius of the circle. Okay, see, then from the figure we will get, it is a right angle triangle, right? So x square plus y square is equal to r, that is r is the radius, so total length is 2r, right? So x square plus y square is equal to 2r whole square, right? From the figure, x square, we get x square plus y square is equal to 2r whole square, right? So here, what is y square? Y square is equal to 4r square minus x square. Okay, then see here, what is the function? Maximum area. So area is the function, right? So what is the area of the rectangle? X is the length and y is the width. Then what is the area? Area of the rectangle A is equal to x into y, that is x into, what is y? 4r square minus x square. Okay, so it is the area. So it's our function. So let's differentiate it. Sorry, x into y, right? So it is y square. So what is y? Y is nothing but square root of 4r square minus x square, right? So here square root, okay, x into root of 4r square minus x square. So it is a. Now let's find a square. So it is easy to find the derivative, right? And we know that if a square is maximum, then a is also maximum. Okay, so let's find a square. A square is equal to x square into 4r square minus x square. Okay, so that this square is removed. Okay, then after that, let's find dA square by dx. Okay, that is first derivative, dA square by dx. That is x square into derivative of 4r square. 4r square is constant minus x square, that is minus 2x. Okay, plus 4r square minus x square into derivative of x square, 2x. That is equal to minus 2x cube plus 2x into 4r square minus x square. Okay, so here minus 2x cube, that is 4x cube. So minus 2x cube plus 8xr square minus 2x cube, that is equal to minus 4x cube plus 8xr square. So it is dA square by dx. So here x is common, right? That is minus 4x into x square minus 2r square. Okay, so here dA square by dx is equal to 0 implies minus 4x into x square minus 2r square is equal to 0. That implies here x is equal to 0 and x square minus 2r square is equal to 0 implies x square is equal to 2r square. That implies x is equal to root 2r, right? Root 2r, plus or minus root 2r. Okay, then here next we will find second derivative, that is d square a by dx square, not a square. Okay, here we are finding the maximum of a square. Okay, so d square a square by dx square, that is equal to, it's our d a square by dx. So here we have to differentiate it with respect to x, that is, okay, let's differentiate it this one. Okay, so minus 4 into 3 12, that is minus 12x square plus 8r square. Okay, plus 8r square. Okay, then when x is equal to 0, see, when x is equal to 0, see here d square a square by x square is 8r square, that is greater than 0. Okay, because radius is always greater than 0, right? Okay, so here this 8r square will be greater than 0 when x is equal to 0. So x is equal to 0 is not possible. Then after that, x is equal to plus or minus root 2r. So here x is equal to minus root 2r. See, it will be square. Okay, when x is equal to minus root 2r, it will be minus d square a square by dx square is equal to minus 12 into x square. It will be positive. Okay, that is, okay, no need to find. Okay, 2r square. Okay, plus 8r square. Okay, that is, here it is minus. So it is less than 0 because minus 12 into 2r square is, that is minus 24r square plus 8r square, that is less than 0. And when you substitute plus root 2r, see here plus root 2r, that is also same thing you will get, minus or plus. Okay, so here if you substitute x is equal to plus root 2r, it will be same things, you will get same value. Okay, so here let's take x is equal to, see, x is equal to minus root 2, that is impossible, right? Because x is the length of the rectangle, right? So here only x is equal to plus root 2r. Okay, so here in this case, here we have got x d square, that is a second derivative, less than 0. So according to the second derivative test, we can say this area, that is a square. Okay, see here a square is maximum when x is equal to root 2r. Okay, so a square is maximum when x is equal to root 2r. Okay, root 2 into r. Then if a square is maximum, then a is maximum. Okay, so a is maximum, therefore a is maximum when x is equal to root 2r. Okay, so x is equal to root 2 into r, then what is y? Okay, we have to find y. Okay, y is equal to, x is equal to root 2 into r, y is nothing but 4r square minus x square, that is x is root 2r, so x square is 2r square, right? That is equal to 2r square. So what is 2r square? 2r square is nothing but, that is, sorry, y square is y, that is, sorry, y is equal to root of 4r square minus x square. Okay, see, y is equal to root of 4r square minus x square, not y square. Here we have to find y, right? See, here we have to prove that, see, when the area is maximum, this rectangle is become square. Okay, then it will be the square, not rectangle. So for square, what we have to prove? We have to prove that x is equal to y. Okay, we have taken a length of the rectangle is x and width is y, right? So we have to prove x is equal to y. Okay, then it is show that, so this the maximum square is the maximum area. Okay, so here what is y? We have got when x is equal to root 2 into r, this a is maximum, a is maximum. So what is y? Let's find. So y is equal to root of 4r square minus x square, that is root of 4r square minus x square is 2r square, right? That is root of 2r square, that is root 2 into r, that is nothing but x. right? See, root 2 into r. So what is root 2 into r? X itself, right? So here we have got y is equal to x. So that means y is equal to x means length is equal to width, right? So in that case, when area is maximum, so that area, that rectangle is nothing but square. Okay, so that is not rectangle, that is the square. That is why here it is a square has the maximum area. Okay, so x is equal to y, therefore the square has the maximum area. Show that the right circular cylinder of given surface and maximum volume is such that its height is equal to the diameter of the base. So here we have to prove that when the volume of the cylinder is maximum, the height and diameter of the cylinder are equal. Okay, so here we have to prove the height of the cylinder and diameter of the cylinder are equal when the volume of the cylinder is maximum. Okay, so here for that let x be the radius. X be the radius. If x is the radius, then what is the diameter of the cylinder? That is 2x, right? Let x be the radius and y be the height of the cylinder. Okay, then the surface area S is equal to, we know that surface area of a cylinder, right, a circular cylinder is 2 pi RH plus 2 pi R square, right? 2 pi RH plus 2 pi R square. Here R is the radius of the cylinder and H is the height of the cylinder, right? So here X is the radius and Y is the height. So 2 pi XY plus 2 pi X square is the surface area of the cylinder. Then, so here we have to find y, right? So S minus 2 pi X square is equal to 2 pi XY. That implies y is equal to S minus 2 pi X square divided by 2 pi X. Okay. Now what is our function? That is volume of the cylinder. Okay. So what is the volume of the cylinder? Right, circular cylinder. We know that volume of the cylinder is pi r square h. Here r is the radius and h is the height of the cylinder, right? So here x is the radius and y is the height. Therefore pi x square y. Now substitute. See here we have to write the terms in x only. Okay. So here substitute y. Pi x square into S minus 2 pi X square divided by 2 pi X. That is equal to, here pi cancelled, X cancelled. So remaining Sx minus 2 pi X cube divided by 2. Okay. So it is V. Now let's find dV by dx. Okay. dV by dx. Here we have to find when the volume is maximum. So what is x and y? We have to prove the height is equal to diameter. Okay. So that is dV by dx is equal to 1 by 2 into derivative of Sx is S minus here 6 pi x square. Okay. Now here dV by dx is equal to 0 implies, okay, let's find d square v by dx square. That is 1 by 2 into derivative of s is, that is constant, 0. So minus 12 pi. That is minus 12 pi x. So that is always less than 0. See, whatever values we give x, for x, so it will be less than 0. X is positive, right? Because x is nothing but radius of the circle. Okay. So it is less than 0. Now, when dV by dx is equal to 0 implies s minus 6 pi x square is equal to 0. That implies s is equal to 6 pi x square. Okay. So what is our x? See, this x is nothing but 2 pi xy plus 2 pi x square, right? So here 2 pi x is common. Let's take it out. 2 pi x into here y plus here x. So x plus y. So let's substitute. This implies s is equal to 2 pi x into y plus x is equal to 6 pi x square. Okay. So here 2 pi cancelled, so it will be pi cancelled, it is 3, and x cancelled, so it is become x. So y plus x is equal to 3x. Okay, that means here take x right side, so that implies y is equal to 3x minus x, that is 2x. See, here we have got y is equal to 2x. What is 2x? Diameter of the x is the radius of the cylinder. So 2x is the diameter of the cylinder, right? What is y? Y is the height. So we have got here we have got volume is maximum, right? That is less than 0. Second derivative less than 0 means the volume is maximum. So when the volume is maximum, see the height of the cylinder, height and diameter of the cylinder are equal. Okay, that is y is equal to 2x. Y is the height of the cylinder and x is the radius, therefore 2x is the diameter. Okay, therefore when the volume of the cylinder is maximum, height and diameter of the cylinder are equal. Of all the closed cylindrical can of a given volume 100 cubic centimeters, find the dimensions of the can which has minimum surface area. So here we have to find the can is in the shape of cylinder, okay, a right circular cylinder, and here its volume is given, that is 100 cubic centimeters, and we have to find the dimensions of the cylinder when the surface area is minimum. That is, dimension means we have to find the radius and height of the cylinder. Okay. So let's take, let x be the radius, and y be the height of the cylinder. Height of the cylinder. Okay. Then what is the volume is given, right? So volume of the cylinder is nothing but pi r square h, right? That is, r is the radius, h is the height. Here x is the radius, so pi x square y. Okay, that is equal to, that implies pi x square y is equal to 100. That is given, right? Volume of the cylinder is 100 cubic centimeters. Therefore pi x square y is equal to 100. That implies y is equal to 100 divided by pi x square. Here we have to find x and y when the surface area is minimum. Okay. So what is our function? Surface area. Okay. So here surface area is the function, right? So what is the surface area of the cylinder? Surface area of the cylinder is 2 pi RH, right? 2 pi RH, that is 2 pi xy plus 2 pi r square, that is 2 pi x square. Here x is the radius of the cylinder. Okay. Then substitute y because we need these terms in x, right? So 2 pi x into 100 divided by pi x square plus 2 pi x square. That is equal to, here pi x cancelled. So 2 into 100 is 200 divided by x, pi cancelled, okay, plus 2 pi x square. Okay, now let's find ds by dx, okay, because here we have to find the dimension of the can, that is dimension of the cylinder when the surface area is minimum, right? So our next step is find ds by dx. ds by dx is, see, 200 into derivative of 1 by x is minus 1 by x square. So minus 200 by x square. Okay, 200 into minus 1 by x square, that is minus 200 by x square. Plus here 4 pi x. Okay, then next let's find d square s by dx square. d square s by dx square. Second derivative. We should get greater than 0 for minimum. Okay, we should get greater than 0. Okay, so here 200 minus 200 into 1 by x square. Derivative of 1 by x square is minus 1 by x cube, right? 2x cube, right? That is d by dx of 1 by x square is, that is minus 2 into derivative of, that is minus 2 minus 1 divided. So, okay, that's all. That's all, okay. So, minus 2 into 1 by x cube, okay. So, here minus 200 by x square, that is minus 200 into minus 2 by x cube. That is minus, so minus minus become plus, so plus 400 divided by x cube plus 4 pi, plus 4 pi, okay. So it is our d square s by dx square, that is 400 divided by x cube, because derivative of 1 by x square is minus 2 into 1 by x cube. So minus minus become plus, so 200 into 2, 400 divided by x cube, plus derivative of 4 pi x is 4 pi, okay. Now, so we have got d square s by dx square. So let's find the x values, okay. So ds by dx is equal to 0 implies minus 200 by x square plus 4 pi x is equal to 0. That implies 4 pi x is equal to 200 divided by x square. That implies here take x square left side, so it will be x cube, that is equal to, take 4 pi here, so 200 divided by 4 pi. That implies x is equal to, see x cube is equal to this one, and see x cube is equal to, cancel 4 50s, right? So 50 divided by pi, that implies x is equal to, x cube is equal to 50 by pi. So what is x cube root of 50 by pi, right? That is cube root, that means 50 by pi whole raised to 1 by 3. Okay, so x is equal to 50 by pi whole raised to 1 by 3. So now substitute x is equal to 50 by pi whole raised to 1 by 3 in d square s by dx square. Obviously it will be greater than 0, right? Because see, divided by a positive number plus a positive number, that will be greater than 0. So here d square s by dx square is greater than 0 when x is equal to 50 by pi whole raised to 1 by 3. That is, when we substitute x is equal to 50 by pi whole raised to 1 by 3 in d square s by dx square, obviously it will be greater than 0. So here this surface area is minimum, greater than 0, right? So okay, surface area is minimum when x is equal to 50 by pi whole raised to 1 by 3. So what is y? We have got radius, okay. Now we have to find height of the cylinder. So what is y? Y is equal to 100 divided by pi x square, that is equal to 100 is nothing but 2 into 50 divided by pi into x is 50 by pi 1 by 3 raised whole square, that will be 2 by 3, right? 2 by 3. So here pi cancelled, right? Pi into, no, not cancelled, sorry, pi, yes, so it is pi raised to 1 by 3, okay, it is pi raised to 1 by 3, so 2 by 3, okay. So here 2 into, it is 50, so 50 by 2 by 50 raised to 2 by 3, it will be 50 raised to 1 minus 2 by 3 divided by, this pi raised to 2 by 3 will come to numerator, so here pi raised to 2 by 3 and this minus 1, okay. So it will be, that is 2 into 50 raised to 1 by 3, it is minus, yes, pi raised to minus 1 by 3. So we can write 2 into 50 by pi whole raised to 1 by 3. Okay, that is we applied power rules. Okay, see here 100 can be written as 2 into 50, right? Because 50 is here, so that we can take it here. So 50 minus 50 raised to 50 means 50 raised to 1. So, okay, so it is 1 minus 2 by 3. Okay, then this pi raised to 2 by 3 will come to numerator and this pi raised to 1. So 2 by 3 minus 1. Okay, then after that 2 into 50 raised to 1 by 3. So it will be pi raised to minus 1 by 3. That can be written as 1 by pi raised to 1 by 3. Okay, so that is 50 by pi raised to 1 by 3. So it is y. What is y? Y is the height of the cylinder. So x is radius of the cylinder. So when surface area is minimum, x, that is x is equal to, radius is equal to 50 by pi 1 by 3 and height is equal to 2 into 50 by pi 1 by 3. Okay. So we can write when surface area is minimum, radius is equal to 50 by pi whole raised to 1 by 3 and height is equal to 2 into 50 by pi whole raised to 1 by 3. Okay, it is the dimension when surface area is minimum.